Okay, so today I'm going to talk about unfreezing robots in human crowds. But I will start with my own story about how I learned to drive, which is not a happy experience. When I drove the car with my coach for the first time on the street, I totally freaked out. There were just so many cars and they were so fast that I thought I would definitely hit one of them if I merged into the street. So instead, I drove the car really slowly near the sidewalk. Unfortunately, my coach is not a man with much patience. After about 1 minute, he literally pushed my leg on the gas pedal, and our car suddenly speeded up and merged into the street. But hey, nothing bad happened. Even though it seemed really dangerous for other drivers, they are not idiots. They will try to avoid hitting me when I merge. So once I realized this fact and I started to trust others, driving became much easier to me. And the interesting thing here is the robot has exactly the same problem as I had, which what we call the freezing robot problem. Traditional robot navigation methods don't trust humans. The robot will treat the humans like boxes or trees, something that will never avoid the robot by itself. And the result is the robot will always be overcautious about hitting others. And when there are too many pedestrians around the robot, the safest action for the robot to do is don't do anything. Similar to unfreezing human drivers like me, in order to unfreeze the robot, we need to make the robot trust human, trust that human will collaborate with it to avoid a collision. The key here is to build a model for human behavior. For example, imagine a robot is driving in a narrow hallway and there's someone else walking towards the robot. Then the first prediction is this guy is very likely to keep walking forward, of course. And the second prediction is, since it's a very narrow hallway, if both the robot and the human move in a straight line, they are very likely to collide into each other. However, instead of driving into the wall and waiting there until the human passes, the robot just needs to move aside a little bit because the model of human behavior can tell the robots that the human will also move aside a little bit to avoid a collision. And in this way, both robots and the human can keep moving and they can achieve the so-called cooperative collision avoidance. This is all I want to share today, and I will conclude my presentation with a quote. At the bottom, robotics is about us. It's the discipline of emulating our lives, of wondering how we work. Thank you.